performance, features, and compatibility with your existing infrastructure and applications. 2. Review system requirements. Before installation, review the system requirements for the chosen DBMS, including hardware specifications, operating system compatibility, disk space, memory, and processor requirements. 3. Download and verify software. Download the DBMS software from the official vendor website or a trusted source. Verify the integrity of the downloaded software by comparing its checksum or digital signature with the vendor's official checksum or signature. 4. Plan the installation. Plan the installation process, including selecting the installation directory, configuring network settings, choosing database options, and setting up authentication and access controls. 5. Follow installation instructions. Follow the installation instructions provided by vendor, including running the installer program, accepting the license agreement, and specifying installation options, such as installation directory, components to install, and startup options. 6. Configure security settings. During installation, configure security settings, such as authentication methods, passwords, access controls, and encryption options to ensure the security of the database environment. 7. Enable encryption. Enable encryption options such as transparent data encryption, TDE, or SSL, TLS encryption to protect data at rest and in transit, safeguarding it from unauthorized access and data breaches. 8. Configure backup and recovery. Set up backup and recovery options to protect against data loss and ensure business continuity in the event of hardware failures, software errors, or security incidents. Configure backup schedules, retention policies, and storage locations. 9. Optimize performance. Configure performance settings, such as memory allocation, buffer pool size, cache size, and query optimization parameters to optimize database performance and ensure efficient use of system resources. 10. Apply security patches and updates. After installation, apply security patches and updates to the DBMS software and underlying operating system to address known vulnerabilities, security issues, and performance improvements. Establish a patch management process to ensure timely deployment of updates. 11. Test and validate installation. Test the installation and configuration of the DBMS by performing functionality tests, connectivity tests, and security checks. Validate that the database is accessible, responsive, and functioning as expected. 12. Document installation and configuration. Document the installation and configuration process, including installation steps, configuration settings, security policies, backup procedures, and any customizations made. Maintain up-to-date documentation for reference and troubleshooting purposes. By following these best practices for installation and configuration, you can ensure a smooth and secure deployment of your DBMS, minimizing the risk of security vulnerabilities, performance issues, and data loss. Additionally, regularly review and update the configuration settings and security measures to adapt to evolving requirements and mitigate emerging threats. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about NewSQL databases, CockroachDB, key features of NewSQL databases, benefits of NewSQL databases, ChalSQL databases, future trends in NewSQL. Let's enjoy. Definition of NewSQL. Of NewSQL databases. Combines the benefits of traditional SQL databases with standard performance as NoSQL compliance and horizontally scalable architecture. Overview of CockroachDB features. Distributed SQL database, strong consistency, horizontal scalability, multi-active availability. Native of relationships, efficient traversal of complex networks, schema flexibility, support for ACID transactions. Combines scalability of NoSQL with ACID compliance SQL, simplified data management SQL interface, high performance for both read and write operations, horizontal scalability without sacrificing consistency. Complexity, managing transactions, performance tuning for distributed queries, operational complexity in managing distributed clusters. Comparison of NewSQL with traditional SQL and NoSQL databases. Use cases where NewSQL databases offer advantages over other approaches. Advances in SQL query optimization, integration with cloud-native technologies, example, Kubernetes. Predictions for the future evolution of new SQL databases. Thanks for watching the Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about multi-model databases, multiple data models, unified data management, flexibility and agility, interoperability. Let's enjoy. Multi-model databases are database systems that support multiple data models within a single integrated platform. Unlike traditional databases that are typically designed for a specific data model, e.g., relational, document, graph, multi-model databases offer flexibility and versatility by allowing users to work with different data models interchangeably. Here are some key characteristics and considerations of multi-model databases. Support for multiple data models. Multi-model databases support a variety of data models, including relational, document, graph, key value, time series. Users to store different types of data, the most appropriate data model for their use case. Unified data management. Multi-model databases provide a unified platform for managing diverse types of data, eliminating the need for separate databases or specialized tools for each data model. This simplifies data management and reduces complexity for developers and administrators. Flexibility and agility. Multi-model databases offer flexibility and agility in data modeling and schema design. Users can choose the most suitable data model for their data and easily adapt to changing requirements without the need for schema migrations or data transformations. Interoperability. Multi-model databases enable seamless interoperability between different data models, allowing users to perform complex queries and analytics that span multiple data types. This promotes data integration and facilitates cross-domain and insights generation. Scalability and performance. Multi-model databases designed to scale vertically, growing data volumes and data indexing, optimization, distributed processing capabilities to performance and scale across diverse data consistency and integrity. Multi-model databases ensure data consistency and integrity across different data models through transaction support, ACD compliance, and data validation mechanisms. They maintain data consistency constraints and enforce referential integrity to preserve data quality. Use cases. Multi-model databases are well suited for a wide range of use cases that involve diverse data types and complex data relationships. Examples include content management systems, e-commerce platforms, social networks, IoT data processing, real-time analytics, and fraud detection. Developer productivity. Multi-model enhance developer productivity by providing a unified API and query language for accessing and manipulating data across different data models. This reduces the learning curve and allows developers to focus on application logic rather than data management intricacies. Integration with existing systems. Multi-model databases integrate seamlessly with existing systems and data sources, enabling organizations to leverage their existing investments in infrastructure and applications. They support integration, replication, and synchronization with legacy databases and external data sources. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about database management system, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management. In this section, we discuss about monitoring and alerting, monitoring tools, metrics, implement automated monitoring, and send data, providing system health, performance, and availability. Here are some best practices for monitoring and alerting in database management. 1. Define monitoring objectives. Define clear objectives and goals for monitoring, such as identifying performance bottlenecks, detecting anomalies, ensuring data availability, and meeting service level agreements, SLAs. 2. Select monitoring tools. Choose appropriate monitoring tools and solutions that meet the requirements of your team. Consider factors such as scalability, compatibility, features, and ease of use when selecting monitoring tools. 3. Monitor key metrics. Monitor key performance metrics such as CPU utilization, memory usage, disk I/O, network throughput, query latency, transaction throughput, and database connections. Track these metrics over time to identify trends and deviations from normal behavior. 4. Establish baselines. Establish baseline performance metrics for your database system under normal operating conditions. Use historical data and performance benchmarks to define baseline thresholds and detect deviations from expected performance levels. 5. Implement automated monitoring. Implement automated monitoring solutions that continuously collect and analyze performance data in real time. Use automated monitoring scripts, agents, or monitoring platforms to streamline data collection, analysis, and reporting processes. 6. Set up alerts. Configure alerts and notifications to proactively alert administrators and stakeholders about performance issues, anomalies, and potential problems. Set up alert thresholds based on baseline metrics, performance objectives, and criticality of the monitored parameters. 7. Define escalation policies. Define escalation policies and procedures for handling alerts and incidents. Establish clear roles, responsibilities, and escalation paths for responding to alerts, diagnosing problems, and resolving issues in a timely manner. 8. Monitor database logs. Monitor database logs, error logs, and audit logs for warning signs, error messages, and security events. Analyze log data to identify performance bottlenecks, security breaches, and operational issues that require attention. 9. Correlate metrics and events. Correlate performance metrics with system events, database activities, and workload patterns to get deeper insights into performance trends and root causes of issues. Use correlation analysis to identify cause and effect relationships between different metrics and events. Conduct capacity planning. Use monitoring data and performance trends to conduct capacity planning and resource allocation. Forecast future capacity requirements based on growth projections, workload patterns, and performance trends to ensure scalability and optimal resource utilization. Regularly review and tune alerts. Regularly review alerting configurations, alert thresholds, and alerting rules to ensure that they remain relevant and effective. Fine-tune alerting parameters based on feedback, changes in workload, and evolving business requirements. Document monitoring procedures. Document procedures, alerting configurations, and incident workflows for reference and knowledge sharing. Maintain up-to-date documentation tools, metrics, and escalation procedures. By following these best practices for monitoring and alerting, database administrators can properly detect, diagnose, and resolve performance issues, ensure data availability, and maintain the health and reliability of their database systems. Continuous monitoring, analysis, and optimization are essential for effectively managing database environments and meeting the performance objectives of the organization. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about machine learning and AI in databases, natural language processing, NLP, data security and privacy, automated insights and data exploration. Let's enjoy. Machine learning, ML, and artificial intelligence, AI, are increasingly being integrated into databases to enhance their capabilities and provide more intelligent data management and analytics solutions. Here are some ways ML and AI are used in creation. ML algorithms can analyze query patterns and historical query execution data to optimize query performance. By learning from past query executions, ML models can suggest better query plans, indexing strategies, and database configurations to improve overall system performance. Recommendation systems. AI algorithms such as collaborative filtering and content-based filtering are used to build recommendation systems in databases. These systems analyze user behavior and preferences stored in the database to generate personalized recommendations for products, services, or content. Natural language processing NLP techniques enable databases to understand and process natural language queries and commands. By incorporating NLP capabilities, databases can support voice search, conversational interfaces, and text-based query processing, making data access more intuitive and user-friendly. Automated data management. AI-driven automation tools can assist in data management tasks such as data cleaning, data integration, and data categorization. ML algorithms can learn from historical data management activities to automate repetitive tasks and improve data quality and consistency. Data security and privacy. ML and AI techniques are used to enhance data security and privacy in databases. AI-powered systems can analyze access patterns and user behavior to detect potential security threats and anomalies. Additionally, NL models can help in data anonymization, encryption, and compliance with privacy regulations such as GDPR. Optimized resource allocation. ML algorithms can analyze resource usage patterns in databases and predict future resource requirements. By optimizing resource allocation, databases can ensure efficient utilization of computing resources such as CPU, memory, and storage, leading to cost savings and improved performance. Automated insights and data exploration. AI-driven data exploration tools can judge datasets stored in databases and automatically generate insights, trends, and patterns. These tools enable users to uncover hidden insights and make data-driven decisions without requiring extensive manual analysis. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about primary keys and foreign keys. Let's enjoy. Keys, specifically primary keys and foreign keys, are crucial components in relational database design. They establish relationships between tables and ensure data integrity. Here's an explanation of primary keys and foreign keys. Primary key. A primary key is a column or a set of columns in a table that uniquely identifies each record in the table. It must have a unique value for each row, and it cannot contain null values. Primary keys are defined when creating the table using the primary key constraint. By default, primary keys also typically have an associated index for fast data retrieval. Example, in a table of employees, the employee ID column could be designated as the primary key. Foreign key. A foreign key is a column or a set of columns in one table that establishes a link to a primary key in another table. It represents a relationship between two tables, where the values in the foreign key columns of one table match the values in the primary key columns of another table. Foreign keys enforce referential integrity, ensuring that values in the referencing table's foreign key columns exist in the referenced table's primary key columns. Foreign keys are defined using the foreign key constraint. Example, in a table of orders, a foreign key referencing the customer ID column in the customers table establishes a relationship between orders and customers. Create table employees. Employee ID, int primary key, first name varchar50, last name varchar50, department ID int, foreign key, department ID references departments, department ID. Create table departments, department ID int, primary key, department name varchar50, for. In this example, in the employees table, employee ID is designated as the primary key. The departments table also has a primary key, department ID. The department ID column in the employees table serves as a foreign key that references the department ID column in the departments table, establishing a relationship between the two tables. This ensures that every value in the department ID column of the employees table corresponds to a valid department ID in the departments table. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about limiting results. Let's enjoy. Limiting the number of results returned by a SQL query is achieved using the limit clause. The limit clause allows you to specify the maximum number of rows to return in the result set. Here's how you can use the limit clause in SQL. Select column 1, column 2, exclamation mark. From table name, limit number of rows. Column 1, column 2, exclamation mark. You want to retrieve data from. You can specify one or more columns separated by commas. If you want to retrieve all columns, you can use star, table name, the name of the table from which you want to retrieve data. Number of rows, the maximum number of rows to return in the result set. Here are some examples of using the limit clause to limit the number of results in SQL. Retrieve the first 10 rows from a table. Select star. From students, limit 10. Retrieve the first 5 rows from a table sorted by age in descending order. Select star. From students, order by age DESC, limit 5. Retrieve the top 3 highest paid employees. Select star from employees, order by salary DES, limit 3. Retrieve the first 20 orders placed in the year 2022. Select star from orders where year order date equals 2022, limit 20. The limit clause is particularly useful when dealing with large data sets or when you only need to retrieve a subset of rows from a table. It allows you to control the size of the result set and improve query performance by reducing the amount of data processed by the database engine. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about key value stores. Redis, key features of key value stores, benefits of key value stores, best practices for working with key value stores, future trends in key value stores. Let's enjoy. Definition of key value stores, characteristics of key value databases, basic data model, pairs of keys and associated values, simplicity and high performance, scalability and fault tolerance. Overview of Redis data model in Redis, key value pairs, features, in-memory data storage, support for various data types, strings, lists, sets, etc., pub-sub messaging, built-in replication and clustering. Simple data model, keys mapped to values, high performance for read and write operations, in-memory and disk-based storage options, support for data types beyond strings, e.g. lists, sets, hashes. High performance and low latency, scalability for handling large datasets, simple data model and ease of use, versatility in supporting various use cases. Comparison of key value and relational data models. When to choose a key value store over a relational database. Choosing appropriate data structures for keys and values, optimizing cache eviction policies, handling data persistence and backups, monitoring and performance tuning. Advances in in-memory computing technologies, integration with other data processing frameworks, e.g. Apache Spark, predictions for the future of key-value databases. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again.